I'm representing DuPont, and inside the sustainable solution business, and with a worldwide presence, and with a lot of business segments. For the marine business, we have the corium, the Centriglass, the paintings in general, the scrubbers, and also the water and fuel technology, and also we offer safety consultancy services. I will be the last boy talking about scrubbers, I promise. I will give you a technology overview, benefits, and also talking about some market trends in the industry. So, as a basic introduction, what is a scrubber? Scrubbers are robust and effective SOx abatement devices to be used for the main engines, but also for the auxiliary engines and the boilers, and using water as a medium for sulfur absorption. In the end of the day, we wash the exhaust gases. Also, as a side effect, scrubbers provide the particulate removal, mainly in mass and not in number. There are 5 basic components of a scrubber system. For sure, a source of water, seawater or fresh water plus a reagent. Then we need pumps, because we need a specific pressure for the spray nozzles, and also because the scrubbers are placed in a higher level in the ships. Then we have the scrubber tower, when we can recognize 3 different sections mainly. The quench section, where we lower the temperature of the gases. The absorber section, where the reaction takes place and we absorb the sulfur into the water. And the droplet separator, where we separate the water from the exhaust so that the exhaust can be dry at the stack. Then we have the treatment plant for the wash water. We provide solution for both the open and the closed loop. And most importantly, the monitoring system, because the acceptance of the exhaust gas cleaning is based on continuous monitoring of air and water parameters. What are the 5 main design parameters that differentiate the different makers? The water flow rates, in the end, how many water we use to scrub the exhaust gases. The inline design and the bypass design. With the inline design, we have the quench section at the bottom. With the bypass design, the quench is on the side. In general, the inline design offers a taller but slimmer solution compared to the bypass design that are fatter but lower in height. Then we have the water and gases mixing method, so the design internal of the tower. So we can offer open spray towers, as we DuPont do, the packet tower, the cyclonic towers, or the oldest plate towers. Then we have the nozzle design and the spray patterners that increase the gas and liquid contact and increase the absorption efficiency. Different makers have different strategies to do that. Then we have the diameter and the height, according to the gas volume that you want to treat. Also the diameter to set the internal velocity for the exhaust gases, and the height because of the reaction time that we need. Why you might need a scrubber? Okay, we listen to many, for sure, good reasons. I will say that mainly for long-term operational flexibility, for 2020 and beyond, against the change on the fuel prices for the marine gas oil, and also for the uncertain availability when the global cap will come. The benefit of a scrubber system. Most of the customers look at the scrubbers only as an upfront investment, but in reality it's a long-term saving opportunity. Even if the fuel prices drop, the differential between heavy fuel oil and marine gas oil is still around $250 per ton. Operators in general can save between 2 or 3 million of pure fuel cost per annum, not taking care of the operating expense of the scrubber. The payback period is always less than 3 years, including installation cost, depending on time spent in ECA now. And the scrubbers are suitable for every ship type. What you can hear about scrubber? For sure you can hear about the pollution of the sea, and that scrubbers are not a mature technology. I will try to expand a little bit about the pollution of the sea. The SOx emissions from shipping are in continuous expansion because the market is growing. That is a good news. But the SOx emission causes dry and wet precipitation. The dry precipitation, like the aerosol, cause asthma, heart, and lung disease, the acid rains on land with a pH of 4 affect the forest, the buildings, and also the lakes. The acid rain on the sea, with the same pH of 4, is kind of different because the seawater acts as a huge scrubber. So thanks to the water alkalinity, we can transform the sulfuric acid into harmless sulfate and sulfites, preventing the water acidification. But for sure, the metals and the particulate matter and the polycyclic aromatic hydrocarbon will still remain in the water because the seawater can do any treatment. With the scrubbers, we avoid all the SOx dry precipitation, the aerosol, and the acid rains. From a ferry, typical ferry, we can save 500 tons of SO2 emission per year per ship. From a larger container ship is 2,000 tons per year per ship. Also, we provide a continuous monitoring of the water quality, so we guarantee the pH higher than 6.5 at 4 meters, that is recognized as a neutral pH. Then we check turbidity as a suspended solid indicator, and the polycyclic aromatic hydrocarbon as an unburned compound indicator. There are still some certain issues about the wash water discharge, for sure. Our mission is to provide the customer with the best available technology in place and well above the IMO requirements. But the problem is that we are constantly pushed to reduce the water flow that causes the lower pH, to reduce the pricing, and to reduce the dimension. And all these topics afflict, in the end, the efficiency of the system. So I think that we should find a good balance between the environment and the cost. And we should work together, makers, customer, institution, for a good balance. Not only looking at cost, but also to environment. So the institution should provide some help. Scrubbers are a mature technology to me because are the most effective technology for land-based application. DuPont started back in 1930 with the first applications. The scrubbers are a part of the inert gas generator system in all the tanker ships from the 60s. And within the 2015, about 50 ships will have a certified scrubbers system installed, certified, and running. Typical operating mode, we discuss a lot. Just to give some highlights, on the open loop that use only seawater with no chemicals is the lowest operating expense configuration. The closed loop, where we use freshwater recirculation plus an alkali, caustic soda, magnesium oxide, or magnesium hydroxide, is the lowest capital expense configuration, but you need to pay for the alkali for sure. The hybrid loop is the most flexible solution, the most adopted in the North Baltic ECA, but is also the highest capital expense solution because it provides both the combination of open and closed loop. Talking about the inline design benefit, we discussed before, there's no side quench, so it's flexible for the in-funnel or in-casing installation for the cruise and ferry ship. The non-ECA mode is available. Exhaust gases can pass through the tower without water. High reliability because DuPont offers a solution without internal packing to increase the liquid over gas contact. And low stability impact because typically the inline design scrubber are fitted inside the casing, not the funnel, so it's a lower height from the baseline of the ship. The inline design configuration is available for single stream and multi-stream. With the single stream, you have one exhaust source and one tower. With the multi-stream, you have multi-exhaust sources from the main engine or plus the auxiliary engine, for example, but only one tower. There are different benefits. With the single stream, it's good for example, mainly for cruise and ferry, because we have less ductwork modification in case of retrofit. The scrubber is optimized for only one source, but for sure offer a high capital expense solution, because for a cruise, for example, you need at least 4 scrubbers. With the multi-stream, it's very popular for the cargo ship, because you have only one funnel at the aft side of the ship. There's no need to design the scrubber for the 100% of MCR from all the sources, but you need isolation valve in the ducts. It's a low capital expense solution. This is why it's very popular for the cargo ship. About the marine scrubber trends, there are about 200 confirmed projects for scrubbers, cumulative. Who is driving the market? The cruise and ferries. Cargo ship are following. There is a slow take-up for the cargo, for obvious reason. Because in the cruise and in the Pax ferry, you have the passenger, so you also offer a green image to the client. About the loop, the hybrid is the most popular, mainly in the North Baltic ECA, followed by the open loop. The pure closed loop is mainly used in the Great Lake region in America, because there's no water alkalinity there. Also, the retrofit are more popular than new builds, because for sure, with the new builds, you also have other alternatives, like the LNG, that to me is not really good for retrofit, okay? For the passenger ship, it's not really suitable, I think. This is a typical scrubber in our workshop in US in January 2015 for a project in the Great Lakes closed loop system. This is our latest installation on board of bark carrier. You can see how easy it is to install the scrubber in this application. Are you ready to jump on scrubber? Thank you very much.